This is part 2 of section 7.4. We want to solve this equation, which means we need to find the LCD and we need to factor everything as much as possible. Well, I can factor a 3 out of here and a 3 out of here as well. They're going to be the same. You get 2x minus 1 on both of these. So for our LCD, we need an x, we need a 3, we need a 2x minus 1. Okay, so I need to multiply all of these by 3x times 2x minus 1. Okay. I'm just writing this over 1 and multiplying each of these with the factored denominator. And again, you may be able to do these, or you probably will be able to do this in your head without writing all of this down every time. But don't be afraid to write things down until you are ready to combine steps in your head. Now, we should lose all of these denominators. Here our x's cancel. So I have 9 times 3, which is 27, times 2x minus 1, plus, here the 3's cancel, the 2x minus 1's cancel, so I have the x left up here, so this is 4x, and this equals, again the 3's cancel and the 2x minus 1 cancels, so I have the x, so this is equal to 2x. Okay, now we need to distribute the 27. And when you distribute the 27, 27 times 2 is 54. X minus 27 plus 4x is equal to 2x. Combine like terms here, that's going to be 58x minus 27 is equal to 2x. Okay, let's subtract 58x from both sides, and you get negative 27 is equal to negative 56x. Divide both sides by a negative 56. So that becomes positive. We get that x is equal to 27 over 56. And I would reduce this fraction if it did reduce. So this is my potential answer. I need to decide whether or not this is a legitimate answer. It does not give me a 0 in this denominator. That one's easy. Now, you can use your calculator and find that it does not give you a 0. You can even plug it in here. Let's see if I do 6 times 27 over 56, and then subtract 3. I do not get 0, so it is okay. You might also, when you have an ugly fraction, if you don't want to use your calculator in that, it might be easier to figure out what does make it 0, just to ensure that you did not get that answer. And what I mean by that, this is like what we did in 7.1. If I take that 6x minus 3 and set it equal to 0 to solve, I'd add 3 to both sides and get 6x equals 3. If you divide both sides by a 6, you get x is equal to 3 over 6, which is 1/2. And as long as we did not end up with 1/2 as our answer, it was going to be good. So it's easier usually to plug in the number and make sure you don't get a 0. But if you have an ugly thing to plug in, you can also go this method. This is the only answer that we'd have to throw away. Or, well, actually 0 as well, but we didn't have to worry about getting that. Okay, so one more. I have 1 over x plus 1, and that does not factor, plus 7 over x plus 6, which also does not factor, is equal to x squared plus 7x plus 6. Now what I'm about to say is not a guarantee, but because of the way the problems are developed, there is a good chance that this factors with these two denominators. Okay, so, but let's look at this. We do not have a GCF, we do not have a square on the end. That's a 1, so we'd get to use the easier method. I'd be looking for two numbers that multiply to a 6 and add to a 7, and that would be 1 and 6. So this does factor with these two denominators. Okay, so we need to multiply everything by the LCD. I need an x plus 1. I need an x plus 6. And that is precisely the same thing. Okay, so what I'm going to do now is, I've mentioned a couple of times that you might get to where you can do this without writing out the LCD by every one. I'm going to talk through that this time. Okay, if I multiply this times this, and this is over 1, the x plus 1s are going to cancel out. And I will have 1 times, if this canceled out, I still have this x plus 6. And again, I wrote the 1 so that you have the pattern. Plus. All right, let's multiply these two. This x plus 6 is going to cancel out this x plus 6. So I have 7 times x plus 1. And then when I multiply these two, the entire denominators cancel out, so the whole thing goes away, and all I have left is a 5. Okay, now let's distribute. Of course, distributing a 1 doesn't change anything, so this is simply x plus 6 plus 7x plus 7 is equal to 5. Combine like terms here. X plus 7x will be 8x. 6 plus 7 is 13. And that's equal to 5. Subtract 13 from both sides. 8x is equal to negative 8. Divide both sides by an 8. And we get that x equals negative 1. Okay, so let's check this. If I take a negative 1 and I plug it in right here, I have negative 1 plus 1, which is 0. So this is thrown out. It would be okay to plug it in here. I'd get a 5. That would be perfectly okay. If I plug it in here, I'm also going to get a 0 because I plug it in right here and I get a 0, and 0 times this is 0. This was my only potential answer, and it had to be thrown away. So this has no solution. There's nothing we can plug in that will make this work.